we're really excited to have Bram here. I'm just going to give everyone a little bit background on why I'm personally excited to have this opportunity. Basically, peer-to-peer systems saw their first wave, I would say like maybe late 90s. You guys might remember Napster and all those golden years. And there were a lot of excitement, just like we are feeling it here today, about the possibilities of peer-to-peer systems. There were all similar applications being proposed. And Bram created BitTorrent. In that in that era. And it is one of the only protocols and projects that kind of survived the first wave of peer-to-peer computing. So I'm extremely honored and excited to actually be able to sit down with Bram and ask him a couple of questions. Awesome. So first of all, you've been involved with decentralized systems for a very long time, right? Like,
yeah.
So the first question is, what is similar and what is different now?
That's a broad question. There are more people who understand rudimentary crypto now, which is not to say there are a lot of people who understand rudimentary crypto, but there are more people who understand
relatively more.
Yeah, the flavor of the projects that people are excited about is rather different in some notable ways. So, like, if you compare like BitTorrent to Bitcoin, right? BitTorrent does a really, really good job of very efficiently using every available resource to its maximum utility, where Bitcoin is sort of the opposite. It does a very good job of wasting every available resource it can possibly get its hands on.
Okay. I'm going to connect back to this later on. What do you think about the community? Do you feel like, do you see certain things that people should try to learn and not try to repeat those mistakes, or something they should be cautious of right now?
Well, when you have these very technical projects, inevitably, inevitably, all the real development is done by a very small cabal of people. It has to be. It's very difficult technical work. And only a rather small number of people have the know-how for how to do it. And there used to be this phenomenon of people really deeply feeling like they should somehow be contributing to these projects by posting on Slashdot. This, back in the day, had to do with endless discussions about open source licenses mostly. Nowadays, things are different. Now people feel very deeply like they should be contributing to these projects by their postings on Reddit, and this has led to endless discussions about hard forks.
So going back to when you were writing the first implementation, and you kind of like released it into the world.
Yeah.
Like, at what point did you start feeling that, oh, I've created something that has a life of its own now, right?
There's a pretty clear date on that one. So I started working on BitTorrent early 2001. And I did a lot of tearing it up, reworking it, blah, 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 rewriting, yada, yada, yada. It's, these things are very difficult things to get working well, and I had this very ambitious plan for how to do it. If you're trying to build a reliable system, this is very different from how people are used to getting systems to work. Usually they think of, oh, you get it working and you do this optimization and that optimization, and it gradually gets better over time. Reliable systems, when you build them, they tend to just not work at all. and have this horrible minutiae of getting it working at all, and then once it's working at all, it's just obliterating the competition because it's a reliable system. So it wasn't until the beginning of 2003, it was sort of like end of 2002, that I kind of declared the protocol final, that I was no longer going to do hard forks on it. And it wasn't, my implementation didn't stop sucking until the middle of 2003 when I finally got Rare's first in there. But it was around the beginning of 2003 that it really started to take off. That it pretty quickly shot up to 8,000 downloads a day from nothing.
And I think at some point it crossed like more than 25% of the internet traffic was actually BitTorrent.
Yeah, it's hard to say because there's backbone traffic and consumer internet traffic and upload versus download and blah, blah, blah. It's a lot of traffic.
So then that brings me to the question that, once you have built something, like you could actually make the decisions, you can actually just write the code, but then it's deployed and it's being used at such a massive scale.
Yeah.
Like, how do you upgrade a protocol like that?
Well, in the case of BitTorrent, I'd already done most of the painful upgrading before declaring it final, so there wasn't very much need.
So it hasn't changed that much?
No, it hasn't. And you want to change in compatible ways. So the terms of art in Bitcoin are hard fork and soft fork, which roughly translates to compatible and incompatible changes in the older vernacular. So you have two peers that are talking to each other, and a compatible change / soft fork is one where they will, if you have a new peer talking to an old peer, they will talk to each other happily, and it will continue to work. And you can have incompatible changes where you can have, where a new peer, if they try to talk to an old peer, the communications they just won't happen. And basically you want to do compatible changes all the time because incompatible ones just kind of don't work. You can have situations where over the course of many years, things can eventually become incompatible. So like in BitTorrent, originally the format that the tracker used to send back peer IP addresses was extraordinarily verbose and stupid because I hadn't bothered to actually look up what IP addresses were. You don't actually, TCP is a black box. You don't actually need to know how anything works. So this was being a problem, so I actually looked up what IP addresses were, and it turns out it's 4 256-bit numbers, so you can just express it as 4 bytes. So I made it so that a peer that was contacting the tracker could send a flag saying, hey, you can send back the data in a compact mode, and then it would be sent back compactly. It was much smaller. And so everybody started doing this. And I think these days, actually, most trackers don't support non-compact. And yet there's this just tradition that you send compact equals 1 to trackers just for nominal compatibility, even though I doubt any trackers today would actually honor it if you didn't send compact equals 1. But this is over, this is more than a decade later after all the old stuff is dead. So you really, really want very long time periods of compatibility before you allow incompatibility to happen.
And what was your experience like with working with Kademlia, the DHT? At some point, I think BitTorrent moved away from it. It had started having different trackers.
No. Our DHT is based on Kademlia, and it's working quite well. We put a number of optimizations into it a few years ago. It really works shockingly well for something that just sounds likely to be attackable. It does a surprisingly good job of being resistant to a number of types of attacks. And we actually went and figured out some stuff a few years ago and put in a few new optimizations. And lookups in it are pretty consistently well under a second on it these days. And an interesting thing, we had this problem where we were trying to add some new features. to it. And looking into how widely deployed our rollouts were, it appeared to be that half the peers were unknown peer types. And we were wondering, wait, is this us like having a bug where we're not sending what our peer type is, or what's going on here? Where did all these peers come from? And I did some digging into it about whether there might be other implementations that do this. And it turns out, if you search on GitHub for DHTs, these days the term of art is when people say the DHT, they mean the BitTorrent DHT. It's like there's only one
the mainline
giant DHT on the whole internet. If you want to use a DHT, this is the DHT to use. The implementations of the DHT don't even bother specifying that it's the BitTorrent DHT. It's just the given one. And there are like dozens of these, some of which appear to be widely used. And we sort of neglected to ask people to put an identifying like version string in the protocol definitions, so they don't. So we don't actually know what implementations these things are by proportion. But the sum total of things that aren't ours that appears in the DHT is about half of them. So any of you out there who are actually doing like DHT implementations yourself, please put in the version information so we know what's going on.
That's for all the engineers sitting here. So let's move into the time era of like post Bitcoin and you know the interest in cryptocurrencies. A lot of people like started getting excited about this again. What do you see is are like you mentioned hard forks? Let's just get right into it. That what do you think are the biggest roadblocks right now that need to be resolved for this field to like progress more quickly?
You know, I think the biggest thing causing problems in development right now, it's pretty easy to identify. It's the miners being butthurt. You know, SegWit 2x was really a remarkably good proposal. So it's mostly about fixing segregated witness. There's basically just a bug in Bitcoin. The fact that it didn't have segregated witness day one was just a mistake. And if you're starting from scratch, this is a trivial fix. Hardly any of the altcoins do it because they don't know what they're doing, but it is trivial to do if you're doing that. And at the time they were working on it, people were complaining like, oh my God, we got to raise the block size limit. So in the process of figuring out how to do segregated witness, the core developers happened to realize that they could, first of all, introduce better hooks for new upgrades in the future, and also de facto increase the block size, the effective block size limit a significant amount. And it's like, wow, this is great. This should be not quite all things to all people, but something everyone should be really happy with and excited about. And prior new Bitcoin extension proposals had gone through like really fast, like alarmingly fast, because mining is actually very centralized, it turns out. So the expectations were that this would just go through quickly, because there wasn't any objective good reason to block it. No, there was no expectation of it. And then the miners just kind of started throwing a tantrum and held it up like a year or two. I'm not sure exactly how long it was, but it was kind of ridiculous. And apparently it was just over ASIC boost that, you know, it's not like miners are running charities. They're trying to make money. And they did what was in their self-interest, which was, or some of their self-interest, which was to try and hold up this change that just happenstance accidentally got in the way of their money. And it's only after some pretty serious, gnarly saber rattling that they finally caved on this one. But they still seem to have this delusion that they can just like do a hard fork and people will follow them. And I think it's very important for just the health and viability of Bitcoin generally that the community at large tells them to take a flying leap and understand their place in the world.
So one thing that we saw because of like this somewhat contentious hard fork is that there were multiple parties emerging. Like people were actually trying to fork the code, trying to form different development teams, and we could identify like different actors. And then obviously you'll see a lot of debate. And I noticed this like one tweet in particular where you said that it's not that I am pro-core, I'm just anti-bullshit, right? So would you elaborate on that a little bit? Like,
well, if you look at it objectively, like what's going on here in terms of development, core has mostly just been doing straightforward normal development, fixing problems, improving scaling, just getting stuff done. And this vitriol that's heaped on them is pretty unwarranted, and most of the justification of it seems to be like, well, they were mean to me, or something like that. Like, oh, what, you came to them with a proposal and they said it wasn't a good idea. Like, what more do you want from them? You really see, it really becomes comical if you look at the development behind these hard forks, right? That like doing the whole justification for just raising the block size limits dumbly was that, hey, it's safe in that it's a super itty-bitty little patch that has very little risk, which sort of kind of has something going for it, but apparently that's not good enough for some people. And they keep making these hard forks that actually have real development in them. And the real development in them is consistently a disaster. It has like these trivial remote denial of service things. The last time they couldn't even get the multiply by 2 right in SegWit 2x, which was really quite something. And it really shows how almost everyone with a clue is behind Core's general roadmap. And there's a lot of heat and light on Reddit, which would give you the impression that there's widespread dissension within the developer community, and it's just not true.
Yeah, so I think for Blockstack, this issue comes up because we want to operate on top of the most secure, most reliable blockchain, and we just don't feel comfortable operating on top of any other network other than Bitcoin right now, right? So it's like we are seeing a lot of different blockchains, but if you look at the quality of engineering work and the depth of like what is needed in terms of actually having a secure network that other people can rely on.
Ethereum's plans to do an unspecified hard fork at some point in the near future don't give you confidence.
So you brought it up. So now I have to ask you more questions here. Like what do you think about like altcoins in general or other large blockchains that are emerging?
So a lot of what people are doing now are these like ERC20 tokens and stuff on Ethereum for their ICOs, mostly because they don't possess the skills to roll out an actual altcoin for the most part, which is not confidence inspiring. As a general rule, if you don't possess the skills to roll out an altcoin, you probably shouldn't be doing an ICO, just saying. And if you look at the altcoins that were coming before that, there's sort of this like threshold of like, is this a serious proposal? And like I said before, segregated witness is just a bug and a pretty easy thing to fix if you're starting from scratch, and so you should do that. I leave you to guess how many altcoins actually did that. But there's another thing, which is the time warp bug, which is so Bitcoin, every once in a while, every 2,000-ish blocks, it resets the work difficulty based on the amount of time that has passed. And it does this by averaging over the last period. There's a bug. There's an off by 1 error, and the first block in this time period isn't factored into the average. So if that one was like half the time, everything's going to get screwed up here. And this can lead to some really crazy attacks. So obviously this is trivial to fix. You just fix the off by 1 bug. And this is a bad, like not good, clearly unambiguous bug. Like segregated witness, I can actually understand how Satoshi made that mistake. I quite likely would have made the same mistake. This one is just a bug, like just unambiguously a bug. Yeah, you can also take a wild guess how many of the altcoins fixed that one.
Interesting. So it's so. Let me shift topics a little bit, and seems like you're working on something new, but there isn't a lot of information about that yet. I was hoping that for the audience here at the summit, maybe you'll actually, talk more about it.
Well, yeah, I gave this talk on it, but the talk was like a 20-minute talk, and I had like 2 hours worth of material, so I was kind of skimming over stuff fast. The plan is to, it's sort of a subtle argument. So there's this question of, hey, can we get rid of the miners in Bitcoin? Because A, this is a lot of wasted resources, which is unpleasant in and of itself. And B, miner centralization is a real problem. This is seeming much less theoretical than it was in the past. And people have come up with a lot of ideas for doing this, and they don't work. And they don't work for an economic reason, which is no matter how it is that you change around what the proof of work is, fundamentally people will take resources, they will take money and throw it at the problem. They will pursue getting the rewards with more money until the amount of money it costs to get the rewards equalizes out. And you can't just get rid of proofs of work because it doesn't work, right? Like proofs of stake systems are having all these problems, and these are deep problems because if they weren't there, we could have made Bitcoin, decades earlier. It's basically K-agreement. You can show that K-agreement just fundamentally has issues, but there's a loophole in it, which is proofs of work. So you can make a secure distributed database if you have a replication strategy, if everything goes everywhere, and just cope with that by having a hard limit to how much data can be added to it, and then have warehouses full of computers burning electricity doing literally nothing, then you can have a secure distributed database, and that's what Bitcoin is. Because this is an economic argument, you need, if you want to get around this problem, you need an economic argument about it. So what you need is some resource that's already there. People already have it, it's already widely distributed, it already has lots of money spent on it, wasted. And it turns out we have such a resource, it's called storage. There's lots and lots of storage space out there in the world that people have on their computers and companies have and yada, yada, yada. Some constant factor of all the storage that's been sold is unused. So if people could mine just based on that storage, just sitting there doing nothing, just showing that they were continuing to sit there and do nothing on it, then this would have all kinds of great properties. It wouldn't be burning electricity, which is really nice, and it would be very hard to attack and very widely distributed, because fundamentally you can't make money investing in mining this way, because people are going to start mining with all this storage space they've got out there, and the rewards for doing it are going to drop to much, much less than the amount that they actually paid for the resources in the first place, because they paid for the resources for some other actual utilitarian reason, and this is just gravy money on top of that. So as long as the amount of rewards that are being handed out is less than the cost of the storage in the first place, and people have paid a lot of money for storage out there, then this is going to work quite well. Now,
really interesting. Yeah. So I was actually gonna ask you one last thought, and that's more about all the engineers who are here, who are young, and they're excited about building decentralized apps. Some of them have actually literally traveled from New Zealand to be here. What advice would you give them about decentralized applications that you think would basically have a significant impact on how they approach this area, or how they proceed with channeling all of their energy?
Decentralized apps are about reliability. And reliability doesn't necessarily mean high uptime. I mean, you hope it means high uptime. That seems to be the point. But the definition of reliability is that there's failover in the system. And that requires a very, very different way of thinking about how your system works than people are used to when they're programming. They're used to, you make a function call, and that function call does exactly what it's supposed to, and it returns. And when you're dealing with a decentralized system, it's like, well, you send a message, and something might happen at some point, and you might get a message later that might indicate something, and your peers might die, and they might fuck with you, and who knows what's going to happen here. And this is just a very, very different mode of thinking than what people are used to. And like, if there's any one thing, I'd like to recommend 2 books. If there's any one book that got me thinking about this, it's the book Transaction Processing by, I believe, Gray and Reuter, that explains kind of the basics of how to think about this stuff. And also, you kind of really should know cryptography. And I do not recommend the book Applied Cryptography. Actually, you should avoid the book Applied Cryptography. Seriously, just don't touch it. Yeah. If you go to cryptobook.us, there's a much better book that's written in a much less engaging style, but has much better information in it. So
cool.
Those
Awesome.
are the 2 things.
I wish we had more time and asked more questions, but I think we are wrapping up here. But thank you so much. This was awesome.